Hi there, and welcome to this lesson. In this lesson, we're learning linear equations, okay? And under linear equations, we're learning to solve equations from word problems. Now, as the lesson progresses, if you have any issues at all, anything comes off as unclear, please feel free to get in touch, okay? We would be more than happy to help. And yeah, let's jump right into the lesson. So linear equations, equations from word problems. Now, word problems, some like it, some don't. Personally, I'm quite fond of word problems. I basically an opportunity to apply math. I like I like doing practical math, which is pretty much the essence of learning math in the first place. We don't just learn it to learn it. We learn math to actually apply it. So, word problems, very interesting lesson. Now let's jump right into it. I have this question here, a word problem, okay? Typical word problem, simple one. Now it says John thought of a number, okay, and then he multiplied this number by 7 and added 3 to this number, okay? Now the result of all of that was 38. What number did he think of? Very simple word problem. Okay, so John thought of a number, he multiplied the number by 7 and added 3 to it, and the result was 38. What number did he think of? And we're basically looking to draw up a linear equation from this word problem. Now, how do we go about doing that? Or how do we solve word problems? Now, when you're faced with a problem like this, simple word problem like this, the first thing you want to do is you want to identify the variable. Okay, first thing you do, identify the variable. What are we looking for? Identify the unknown, and in this case we're looking for a number, the number that John thought of, and we're going to call that number x. Okay, so we're assigning a variable to that number, we're assigning a letter to that number. You can call your number x, y, z, a, b, c, m, n, o, p, whatever you want to call it, but basically I decided to call my x. Okay, and I have my number as x, and then the next thing I want to do, next thing you'd want to do is you want to define the various parameters and their relationships. Okay, so basically we've identified a variable, and looking through the word problem, we want to find out exactly what happens to our variable. So John thought of a number, our number is x, and then he multiplied this number by 7. Okay, so the first thing John did is x times 7, number times 7, and it gave us 7x. Okay, and right after doing that, he then added 3 to the result. So the result is 7x, and then he added 3 to that result, so 7x plus 3, and basically we've been told that the result was 38. So 7x plus 3 equals 38. And at this point, we have a simple linear equation. If you noticed, we have 7x plus 3 equals 38. And we can now go ahead and solve for x. Okay, final step is to solve the equation. We can go ahead and solve for x, and we can say 7x plus 3 equals 38. Let's move 3 over to the left. Okay, move 3 over to the right, sorry, and basically we have 7x equals 38 minus 3. 7x equals 35. We divide both sides by 7, and what we have in the end is we have that x is 5. Very simple. So basically you're looking to solve a word problem, simple word problem like this. Very important that you read the entire word problem before you start solving. Okay, so read the word problem and then start solving it. So we read the word problem. John thought of a number, he then multiplied it by 7 and added 3 to it. If the result was 38, what number did they think of? Okay, so first we identify our unknown, okay, and we call it whatever we want to call it, x, y, you can call it m, you can call it b, d, whatever you want to call that number. Okay, and then define the various parameters and their relationship. So you look through the word problem and you want to find out exactly what's happening to your variable, and in this case the variable was multiplied by 7 and then 3 was added to it, and basically you have multiplied by 7, x times 7 gives you 7x. You have 7x plus 3 equals 38, and from that point you just solve the equation. And yeah, now let's do a few examples. So I have an example here, an example 1. And example 1 says the length of a rectangle is 5 centimeters longer than its breadth. Interesting. Now, if the perimeter of the rectangle is 42 cm, find the breadth of the rectangle. Okay, so how do we go about solving this? The first thing we want to do, like I said, is we want to identify our variable. And in this case, what we're looking for is the breadth of this rectangle. And I'm going to call this breadth B. Now, what exactly is happening to B? Okay, so basically we've been told that the length of the rectangle is 5 centimeters longer than its breadth. And we were told the perimeter of the rectangle is 42 cm. Okay, so length is 5 plus B. Okay, the length is 5 centimeters longer than the breadth, so we have our unknown as B, but we're told that the length of this the rectangle is 5 plus B. Now we know that the perimeter of a rectangle is 2 times length plus breadth. Okay, and we're just going to substitute length 5 plus b for length in that formula. Okay, so instead of length we write 5 plus b because we've been told that the length is 5 centimeters longer than the breadth. So length is 5 plus b. Now if we add that up, so length is 5 plus b. Okay, so the perimeter, length is 5 plus b, so the perimeter is 2 times 5 plus b plus b. What we have is that the perimeter is 2 times 5 plus 2b. So we're breaking it down up until this point, and then the final piece of information you have there is that the perimeter of the rectangle is 42 cm, i.e. 42 equals 2 times 5 plus 2b. And I believe you'd agree with me at this point that we do have a very simple linear equation, and the next thing we're going to do is we just go ahead and solve said linear equation. And we have 42 equals 2 multiplying 5 plus 2b. We expand that out, and what we have is 42 equals 10 plus 4b. Okay, and if we simplify, move our terms around, basically have all the variables on the left and then the numbers on the right, you have 4b over to the left, and if you move things around you should end up with 4b equals 42 minus 10, and basically you have the 4b equals 32, and when you divide both sides by 4 you'd end up with b equals 8. Very simple, very straightforward. Let's move on. Now example 2. And example 2 says if Frank was half his current age 5 years ago, how old is he now? Now this looks quite interesting. So Frank, we have this bloke Frank, and he was half his current age 5 years ago. Okay, and basically we've been asked how old is he now. So first thing, our variable, what are we looking for? We're looking for his current age, and his current age is x. Now 5 years ago Frank was x minus 5. Okay, so 5 years ago Frank was x minus 5, i.e. basically his current age is x. That means 5 years ago he was x minus 5. If, for example, if you're 20 years old at the moment, 5 years ago you were 20 minus 5, 15. So if Frank is x years old now, that means 5 years ago he was x minus 5 years old. Now we're also told that 5 years ago he was half his current age, i.e. 5 years ago he was half of x. Okay, so his age 5 years ago is x minus 5. His age 5 years ago is 1 over 2x. I believe you'd agree with me that x minus 5 equals 1 over 2x. Okay, and basically if you look closely we have an equation. Okay, and we'll just go ahead and solve this equation. So x minus 5 equals 1 over 2x. We'll simplify, we just make that simpler. 1 over 2x, that's x over 2, and basically we have that we'll bring x over 2 over to the left. We have x minus x over 2 equals 5. We have, if you work that, x minus x over 2 is x over 2. X over 2 equals 5. And basically when you cross multiply you have that x equals 10, and yes, Frank is 10 years old. And if you look at it, basically if you apply your answer to the question, you have that x equals 10, and 5 years ago Frank was 5 years old, i.e. half his current age, 10. So yeah, let's do one final example, example 3. Ooh, and example 3 looks quite interesting, but let's get into it. So A man travels 29 kilometers on a good road at a certain average speed. Okay, now on a bad road, he reduces his speed by 42 kilometers and found that it takes him the same time to cover 15 kilometers on the bad road. Now find his average speed on the good road. Okay, so we have this man traveling on two roads apparently, and basically he traveled on a good road, basically on a smooth road, and he traveled at a certain speed. Okay, and then he moved over to a bad road and obviously had to cut down his speed, and then he reduced his speed by 42 kilometers and found that it took him the same time to cover 15 kilometers. So it took him the same time to cover a smaller distance on the bad road because he obviously reduced the speed. So we've been asked to find the average speed on the good road. Now how do we approach this? Now, what is our variable? What are we looking for? We're looking for the average speed on the good road, and we're going to call the average speed on the good road x. Okay, now let's call the average speed on the bad road y. Okay, and basically we've been told that y equals x minus 42. Okay, so basically he was traveling on the good road at a certain average speed, and then he moved over to the bad road and he had to reduce his speed by 42 kilometers. So the speed on the bad road is x minus 42. Now the time on the good road, the time it took him to cover the distance on the good road is 29 over x. Okay, and basically the time on the bad road is 15 over y. Okay, let's look at this. Basically time equals distance over speed. Okay, so if you're looking to find the time it took him to cover the distance on the good road, you divide the distance 29 kilometers by the speed x. Okay, now the time on the bad road, the time it took him to cover the distance on the bad road is also 15 kilometers, the distance it covered on the bad road, divided by the speed on the bad road y, i.e. 15 over y, or 15 over x minus 42, as we already established. Now one final important piece of information that we got from the question was that it took him the same time to cover distance on the good road as it did on the bad road. So basically we have that 29 over x equals 15 over x minus 42, and if you notice we have our equation. So we just go ahead and we'll cross multiply, and basically we have 29 multiplying x minus 42 equals 15 multiplying x, and basically we have that 29x minus 1. When you expand, 29x minus 1228 equals 15x. We'll have 29x minus 15x equals 1228, and what we have in the end is we have that x is 87 kilometers per hour. So yeah, that brings us to the end of this lesson. Okay, equations from word problems. Just a few word problems we had to solve, and basically just 3 things you need to take into consideration when you're solving word problems. First of all, find the unknown, define the parameters, basically understand what the question is saying, what exactly is happening to your unknown, and then draw out an equation, and then just go ahead and solve said equation. And yeah, bye for now.